Hello guys, my name is Jonathan Piliali. I'm from Information System 2018. So today I'm gonna talk about what is graph and rectangular crossing number. Before that, don't forget to subscribe, like and share. Thank you. What is graph? A graph is a picture designed to express words, particularly the connection between two or more quantities. A simple graph usually shows the relationship between two numbers or measurements in the form of a grid. If this is a rectangular graph using Cartesian coordinate system, the two measurements will be arranged into two different lines at right angle to one another. One of these lines will be going up, the vertical axis. The other one will be going right, the horizontal axis. These lines, or axes, the plural of axis, meet at their ends in the lower left corner of the graph. Both of these axes have tick marks along their lengths. You can think of each axis as a ruler drawn on paper. So each measurement is indicated by the length of the associated tick mark along the particular axis. A graph is a kind of chart or diagram. However, a chart or a diagram may not relate one quantity to other quantities. Flowcharts and tree diagrams are charts or diagrams that are not graphs. What is rectangular crossing number? Well, you know 0 has an oval shape, but are you having a hard time figuring out what number looks like a rectangle? Don't worry, there isn't one. Rectangular numbers are special numbers that can be shown by making the shape of a rectangle using an array, which is objects placed in an arranged order using rows and columns. Rectangular numbers are special numbers that can be shown by making the shape of a rectangle using an array, which is objects placed in an arranged order using rows and columns. The number 2 is a rectangular number because it is one row by two columns. Add the rectangle and try to imagine the number of objects you can use in an array form to fill that rectangle evenly. Some numbers you should have came up with are 2, 6, and 8. Most even numbers, or numbers ending in 0, 2, 4, 6, or 8, can form a rectangular shape. The number 2 is a rectangular number because it is one row by two columns. The number 6 is a rectangular number because it is two rows by three columns, and the number 8 is a rectangular number because it is two rows by four columns. However, 4 is the only even number that cannot form a rectangular shape because it forms a square with an array of two rows by two columns. In the mathematical field of graph theory, a complete graph is a simple undirected graph in which every pair of distinct vertices is connected by a unique edge. A complete graph is a directed graph in which every pair of distinct vertices is connected by a pair of unique edges, one in each direction. A drawing of the Heawood graph with 3 crossings. This is the minimum number of crossings among all drawings of this graph, so the graph has crossing number CR, G equals 3. In graph theory, the crossing number CR, G of a graph G is the lowest number of edge crossings of a plane drawing of the graph G. For instance, a graph is planar if and only if its crossing number is 0. Determining the crossing number continues to be of great importance in graph drawing, as user studies have shown that drawing graphs with few crossings makes it easier for people to understand the drawing. The study of crossing numbers originated in Turin's brick factory problem, in which Paul Turin asked for a factory plan that minimized the number of crossings between tracks connecting brick kilns to storage sites. Mathematically, this problem can be formalized as asking for the crossing number of a complete bipartite graph. 2. The same problem arose independently in sociology at approximately the same time, in connection with the construction of sociograms. 3. Turin's conjectured formula for the crossing numbers of complete bipartite graphs remains unproven, as does an analogous formula for the complete graphs. The crossing number inequality states that, for graphs where the number E of edges is sufficiently larger than the number N of vertices, the crossing number is at least proportional to E3/N2. It has applications in Gaussian design and incidence geometry. Without further qualification, the crossing number allows drawings in which the edges may be represented by arbitrary curves. A variation of this concept, the rectilinear crossing number, requires all edges to be straight line segments, and may differ from the crossing number. In particular, the rectilinear crossing number of a complete graph is essentially the same as the minimum number of convex quadrilaterals determined by a set of endpoints in general position. The problem of determining this number is closely related to the happy ending problem. Thank you for watching.